Hello, dear students and parents. Welcome to Become a Good Problem Solver event organized by the GEM Foundation. In this event, we are going to see the solution for senior math problem published on May 2026. The math problem published is related to geometry, and geometry problems are always interesting and tricky because it needs children to not only comprehend the problem but also infer more details from the given information. Let's see how children can develop that skill of inferring the information and translating it to statements so that they can solve the problem systematically using the four-step framework called UPA technique: understand, plan, execute, and reflect. Understanding a problem is half solved. So to understand a problem, children can follow some basic steps like underlining the key terms to identify what is the given information and what is the question that has to be found out, how to ask guiding questions to figure out how the given information can be used to get the solution. They can also visualize, rephrase in order to find the patterns and the relationships between the given information. So these are some of the techniques that you can apply to work on a problem systematically, and we'll see how these can be applied in the given geometry problem. So this is a very interesting problem which is involving some inference that children has to develop, a basic skill in a very middle level problem, but then it will help them relate the concepts. So let's read the question. Each of the triangles PQR and STU has an area of 1 square centimeter. So meaning you can see here PQR is the bigger triangle and STU is the bigger triangle. They are kind of on top of each other. So each of them are 1 centimeter area, right? And then in triangle PQR, the points V and W are midpoints of the sides. So this is like the midpoints of the sides, and in triangle, so we'll draw midpoints of the sides. In triangle STU, points RVW. So this is STU, and RV and W are the midpoints of the sides. Okay, what is the area of the parallelogram UVRW? So this is the parallelogram UVR and W. So what is the area of this parallelogram is the question. So for to work on this systematically, let's ask some guiding questions to understand basically what does this information given mean. So the first question says, what does midpoint of a side mean? So what does it mean when I say V is the midpoint of this side PR? What does it mean? What information can be inferred and written based on the midpoint? So midpoint basically means if you have any line segment, say that this line segment AB is 6 centimeter, and what does the midpoint mean? The midpoint means it is the middle point C such that AC is 3 centimeter and CB is 3 centimeter, right? So midpoint is basically dividing the segment into two equal parts. That is what you can mean. So how do I write it in this case? When I say V is the midpoint of P and R, what does it mean? It means PV is equals to VR. Similarly, what does W is the midpoint mean? Then UW is equals to WS. So similarly, it comes for RV, everything, right? RV and W. So R is the midpoint of TS. So then it means TR is equals to RS. And V is the midpoint of UT, meaning UV is equals to VT. And similarly, W is the midpoint, meaning UW is equals to WS. So these are the points that we can collect by the given information inference. So this is the inference of what does a midpoint mean. So then it says what we need to find is the parallelogram's area, and you might be knowing the area of the parallelogram. To find it, you may need the height and the base, but in this case we might not know the height, right? We might not know the height, and also we might not know the base. So the base we need to figure out. The only thing given is the area of the bigger triangle is 1 square centimeter. So we need to somehow relate the sides, midpoints and the sides given, so that we can find the area of the parallelogram. So let's see what does the parallelogram's properties mean, because they have given that this is a parallelogram. The UVRW is a parallelogram. So when someone is telling that UVRW is a parallelogram, then what does it mean? Opposite sides of a parallelogram are equal, right? So VR is equals to UW is what we can infer. Similarly, VR is equals to UW and VU is equals to RW. See, these are the two opposite sides which are equal. What else can you find out from the parallelogram? So this is a very important question, the very critical point that will help you proceed further, because now we know the sides which are all equal, right? So these sides are equal. So since VR is equal, then you also know that TR is RS. So this um, let's take this as a picture here. So the TR, so we can take it and then have it for reference here, so that we'll use it. Okay, yeah. So there is a very interesting thing in geometry problem, that it is very important to untangle each kind of a knot, so that you get to see the bigger picture very well, and also see how the problem is so simple. So here we have figured out that the sides are all equal, right? You know, the PV and VR are same, and the VR and UW are same because of the parallelogram. And then also UW and WS are same. So then if we can have the colors being mapped here, that which sides are all same, you can actually get that the sides VR, UW, PV, WS are all same, right? And you see the bigger parallelogram PRSU. There is this bigger parallelogram PRSU. So there are so many parallelograms that you can also see here. Now the point is, when in a parallelogram, when you actually draw a diagonal here, what does a diagonal makes to a parallelogram? The diagonal VW makes the parallelogram into two congruent triangles. What are those congruent triangles? UVW, and here it will be RWV. So UVW is congruent to RWV, because UV and RW are same, and VW is the common diagonal between these two sides. So what congruency rule are we applying? Triple S. So based on the triple S congruency, we can say that these two triangles are same. So since these two triangles are same, what does it mean with respect to area? Because we are asking to find the area of the parallelogram. So then we can say that two congruent triangles, they are having equal area. So we can say that area of UVW and RWV are same, right? They both are same area. And now, as you could see, there is also another interesting, I'll maybe use a different color here, blue color, to see another parallelogram, which is this one, the smaller one. So in this parallelogram, what is the parallelogram's dimensions? You can say it as RSWV. So RSWV, this is a parallelogram, and in this parallelogram RW is the diagonal, And what are those two congruent triangles in this parallelogram? You can see that this blue one and this bottom one are congruent, meaning VRW is congruent to SRW, right? So what does it mean then? Area of VRW and SRW are same. So these two are same, right? These top and the bottom, the sides are same. The area are same. So now we know that this top triangle and the bottom triangle area are same, and the W RSW, SRW and VRW, they are also same. So these three triangles are same, and earlier we also concluded that some of the midpoints are same. So based on that, we know that this triangle is congruent to this triangle. How you can also apply the same parallelogram theory here, telling that this is a parallelogram that we are going to see. I'm going to erase these blue ones now, so that the other congruent triangles can be seen here. The TRWV, so that is a parallelogram, and in that parallelogram we have VR as the diagonal, right? So VR is the diagonal of this parallelogram. So this area, these two triangles are actually congruent. So the parallelogram is TRWV, and then diagonal is VR is the diagonal, and in this diagonal you have two triangles, which is a WRV, which is congruent to TRV. So therefore these two area are same. So we have now concluded that the triangle on this top, which is 1 and 2 and 3 and 4 triangles have congruent, and they are also having equal area. So same way you can also find the parallelogram here. So this parallelogram UVWQ, and say that this area 1 and the 5 are same, and can say that the parallelogram VW and UP, based on that the parallelogram 1 and it has the congruent parallelogram triangle 1 and the sixth one. So these two areas are same. So what does it essentially conclude is the all the six equilateral triangles that you can see here. So basically the triangle 1, 2, 3, 4, 5 and 6, all of these triangles are congruent and all are having equal area, right? So this is a very important finding which will help us proceed further, because the triangle PQR in the given information, it is having a area of 1 square centimeter and is made of how many small triangles? So PQR is made of triangle number 1, 2, 5 and 6, so 4 triangles. So then what is the area of just one triangle UVW? So one triangle UVW area is, so it should be 1 by 4, because there are 4 equilateral triangles, equal triangles. So 1 by 4 square centimeter. Similarly, if you can see here in the triangle STU, it is made of the triangles 1, 2, 3, 4. So triangle STU is made of the triangles 1, 2, 3, 4, and it is also having an area 1 square centimeter. So this top UVW, we found it as 1 by 4, and with that itself we can say that since 1 and 2 are same, 2 should also be 1 by 4. But we are also trying to see that based on this 4 equal parts, the triangle 2 is also 1 by 4. And what is that triangle? It is the VWR. So triangle VWR area is also 1 by 4 square centimeter, and the parallelogram is made of actually these two triangles, congruent triangles, and therefore the area of the parallelogram is the area of triangles UVW and VWR, right? So which is 1 by 4 plus 1 by 4, and that is half square centimeter. So this is a very interesting yet simple problem which needs a very important critical information that a student should draw. What is that? Is basically you should try to understand that the you cannot apply the formula, area formula of a parallelogram, which is the length into height, the length, like the height into the length. But then what else you can do with the given information is that finding similar parallelograms, and by drawing the line VW. So this is the first important point, drawing the line VW and applying the property of a parallelogram that the diagonal cuts the parallelogram into two congruent triangles. And what does congruent triangles mean, right? And comparing them with the area. So these are the three important points which is known to all students, but what is important is to connect them and apply it in the problem to find a solution. So that is what children will learn by working on such problems. So I hope students can follow this discussion and start understanding how to work on geometrical problems. And stay tuned for BGPS problems posted in the middle of every month, 15th, and you can have 15 days to submit your solutions. You can find more details on the gymfoundation.com/bgps. Thank you.